Hello students, I am Dr. HarshDev. I am going to give you the introduction of discrete mathematics, and also I will start one topic that is called mathematical logic. So what was the motivation behind studying this discrete mathematics subject? So actually discrete mathematics is the mathematical language of computer science. That is, every subject that you will study in the subsequent semesters, it will involve discrete mathematics topics. So it is very important subject because it will give you the foundation of the subsequent subjects that you are going to study in the subsequent semesters. So the books recommended are, the important book is Kenneth H. Rosen, whose publisher is McGraw-Hill, and Tremblay and Manohar, whose again publisher is McGraw-Hill. And one important another book is Discrete Mathematics by CLU. Its publisher is again McGraw-Hill. So now let us understand what are the problems that can actually be solved using a discrete mathematics. Some examples are there. For example, if I wanted to know how many ways are there to choose a valid password on a computer system, it involves discrete mathematics. How to find what is the probability of winning a lottery? That is also a problem of discrete mathematics. Is there any link between the two computers? How can I encrypt a message so that no unintended recipient can read it? Similarly, what is the shortest path between the two cities using a transportation system? How it can be proved that a sorting algorithm correctly sorts a given list of numbers or anything? How many valid internet addresses are there? So these are the some questions that actually this answers can be given by the discrete mathematics. Now, what is discrete mathematics? So let us see the formal definition of the discrete mathematics. Discrete mathematics, which is also called a finite mathematics, is the study of mathematical structures that are fundamentally discrete in the sense that its object can assume only a distinct or a separate values rather than a continuous values. That is why we say that it is a discrete structure, because we will study all the structure which are discrete in the sense that its object can only assume a distinct or a separate values. Right. Now, what are the basics of this one? So basics of all digital information systems, it actually is a discrete system. Now, image in computer can also be stored in the form of discrete values, which is called pixels, right? And computers use discrete structures to represent and manipulate the data. And computer science is all about solving the problems. So that, which is also called a study of discrete mathematical objects and structures, right? So it means that discrete mathematics, when we say that, we will be talking about the various discrete mathematical structure that we will be studying in the subsequent modules that we are going to study. So what are the discrete structure? Let us see some very few examples. The one is sets. So sets again contains maybe contain discrete values, and graphs, which is also a discrete structure, Boolean algebra, groups, rings, fields, mathematical logic, these are all discrete structures. Let's talk about the sets. If you talk about the sets, every set definitely contains some discrete values, discrete sets, which may be a, b, c, x, y, z. There may be operators, and there are different rules and formula that will formulate the entire system of sets. So every the structure will have certain variables, certain operations, and certain rules and formula that will be actually used in the particular type of the discrete structure. Another discrete structure is the graphs, which is nothing but a set of vertices and edges. Vertices are also discrete, edges are also discrete. That's why it is a discrete structures. So vertices are represented, suppose it is represented by v1, v2, v3 are the vertices, edges are known as E1, E2, E3. These are the edges. So these are all discrete. Various operation we can perform on these one is a union, intersection, and so on. Algorithms we can perform on the graphs is actually Dijkstra algorithm, Kruskal algorithm, Prim's algorithm, and so on. So it is another different type of discrete structure. What are the applications? There are many numerous applications of this subject. For a few very important applications are cryptography. So where we use various encryption and decryption techniques or in algorithms. Similarly, designing a computer algorithms. So computer programmer use discrete math to design efficient algorithms. Similarly, database operations, right, and so on. So there are many applications of this discrete mathematics. Now, other applications are the lattices and Boolean algebra, which is also a very important part of this one, which is used as well as in communication and networking systems. Similarly, recurrence relation, which is very important thing with respect to the programming that we writing a recursive programs. Similarly, combinatorics is all about the counting principles, which is used to find out various type of problems related to counting that we will see in the later on. So these are the things. So what are the applications of graphs that we will study? So it is used in social networks, social networking sites, communication networks, information networks, software design, machine learning, and extract many more topics. Right now, what is the outline of our syllabus? The module 1 basically contains sets, relations, and functions, mathematical logic, and proof methods that we will study. In module 2, algebraic structure like groups, rings, and fields we will be studying. In module 3, partial order relation, lattices, Boolean algebra we will be studying, and logic gate, digital circuits basically we will be studying, and also the mathematical logic and the propositional and predicate logic will be studying, which will start today itself in our lecture. Module 4 contains all about the combinatorics and the graph theory. These are the things that we will be studying, right? And it also includes recurrence relation, generating function, as well as the graph theory, which includes graphs and trees. So this is the basic outline of our entire syllabus that we are going to study. If you talk about the module 1, which so the description of the module 1 is the sets. First we will study sets, then relations, various type of relations that we will study, then the functions, various type of functions, and recursive functions, growth of function, that these are topics we will be studying. And mathematical induction we will be studying, various proof methods we will be studying, different type of proof methods are there. What are the applications of this module 1? Database operations that we can use, we use in database, that actually involves basic discrete mathematics, right? In module 2 we'll be studying discrete structures like groups, then we'll be where different type of groups we will be studying, and then we'll talk about the rings and fields. So these are the topics we'll be studying in the module 2. Applications are coding theory, cryptography, encryption and decryption. We use a field and rings and fields and for data encryption and so on. Right. Similarly, in module 3, we'll be studying. We'll start with the partial order sets. Then we'll talk about the hash diagram. Then we talk about the lattices and various different type of lattices. And we'll also be studying the Boolean algebra, its axioms, and so on. And we will also see how to simplify the Boolean functions using K-map and other methods, right? And various type of digital circuits we will be studying. The applications are many more, which is used in communication, networking, and cryptography as well, modeling and simplifying the switching or relay circuits. So these are some applications, right? Then in the next module we'll be studying the mathematical logic. There are two parts of mathematical logic: propositional logic and the predicate logic that we'll be studying, which is a very important part of the machine learning as well and AI. So the applications are inference and decision making systems, web search engines, right? Solving logical puzzles, artificial intelligence, queries to databases and search engines, design of digital electronic circuits, and so on. And the last module is about the first we will study the graphs. In graphs we will basically study the trees and various type of trees. Then in graphs we will be studying various type of graphs, multigraphs, bipartite graph, planar graph, isomorphism, homomorphism, as well as Euler and Hamiltonian graphs. Also the graph coloring problems. Then we'll study the reconciliation and churning function, which is again advanced counting technique, which is also used to write the recursive programs as well. In combinatorics, we will study the various counting techniques and advanced counting techniques like pigeonhole principle and so on. What are the applications? Shortest pass problems can be solved using this one. Fast searching can be done. Then analysis of algorithms, recursive solutions of the problems, advanced counting problems, right? So these are the things that we will be studying. So this was all about the subjects, but we will I will be starting this first thing about this subject, that is called a what is called a inferential logic, and what about what is called a mathematical logic. So let us understand what is inferential logic. Suppose I write a statement to say you that if I get good marks, then I will go to see the movie. And the second one says that I already got the good marks this time. So what is the conclusion? Definitely the conclusion is therefore I will go to see the movie. So here, using these two statements, statement number 1, statement number 2, we are able to conclude the given conclusion that I will go to see the picture, see the movie. However, I am able to reach to this conclusion. It is because there are only two statements. You can process this statement in your mind logically, and then you can conclude it very easily. But what about the thing whenever these statements are not two? Say suppose these statements are 3000. Can you really draw a conclusion from the given 3000 statement? Definitely not. Why? Because you cannot remember the 3000 statements simultaneously. Even if you remember, you cannot process these 3000 statements to reach up to the final conclusion. So how to solve these type of problems where which involves thousands of statements and you want to draw the conclusion from the given statements? So for that one, we use a concept of mathematical logic. Why we use mathematical logic? Why we say not only logic? It is because computer has to take a decision, and decision cannot be taken by you just giving the input as a text to the computer system, right? So there should be certain type of different type of mathematics we should will be involved, that will actually convert these statement into a symbolic form, that is mathematical symbols, and then we can apply various formulae and uh, statements, and so that we can actually draw the conclusion, but it will involve some mathematical part. So for that one, we actually use a concept of mathematical logic, which is actually really designed for especially implementing into the computers, right? So this type of system that involve a lot of statement, it requires large memory, which is definitely there in computer, and high computational power to draw the particular conclusion. So here the computer can actually be used to solve these type of problem very easily, but we have to create a new type of mathematics for converting these thousands of statement into some mathematical type of statement, so that it can easily be processed by the computer, right? So let us see. So what is mathematical logic? So mathematical logic is actually a tool for working with a large number of complicated compound statements and methods of reasoning. The methods of reasoning means there are different type of rules and formulae that will be provided to you, right? And that will be actually used to draw a particular conclusion from the given argument. So there are two types of mathematical logic part that will be studies. First one will be called a propositional logic and the second will be called a predicate logic. So first we'll be studying the propositional logic. So I have one question with you. Can you tell me the difference between the sentence and statement? So definitely, what, for example, suppose I say that sun rises in the east. Definitely this is a true statement. So it is actually a statement. May God bless you. May God bless you. You cannot say that it is true or false. It is just a sentence. So this is only a sentence, but the earlier sentence, which is sun rising in the east, is definitely a statement. So what is a statement and what is the difference? How it is different from sentence? Every statement has certain truth value. That is called, it will be either true or false. But sentence cannot have a definite truth value, true or false, which is given as a second example. Where are you? It is also just a sentence, not a statement. 3 is a even number. So it is definitely a statement whose truth value is actually false, because 3 is not an even number. But you can definitely say that this is a false statement. So this is what is the difference between a statement and sentence. And in the entire rest of the part of this mathematical logic, we will be talking only about the statement, because every statement has some certain truth value, either true or false. We will not be considering the statements, right? So first one is what is called a proposition. First definition that we are going to study. So statement is also called a proposition. So instead of saying a statement, will say that it is a proposition. So what is a proposition, which is also called a statement, is a declarative sentence that is either true or false, but not both, right? And it will be called its truth values, which will be represented by either true or F, that is T or F. And we will be using uppercase letters which are used to denote the various propositions. It may be PQR, it may be ABC, it may be X, Y, and Z. For example, suppose there is a statement given, John is an intelligent boy. How can I convert it into a symbolic form? I can take any symbol from this one. So suppose I have taken I. So capital I is actually a symbolic representation of this entire statement. Similarly, John is a good boy, so I can say that it is G symbolically. 2 is an even number, so it is definitely a true. So I can take E as a symbol for representing the statement 2 is an even number. Similarly, X I have taken, X is an even number, A is a vowel, so I can take V as a statement to say that A is a vowel. So for every statement in proposition logic, we actually convert it into a symbol, which will be called a symbolic statement. So I, G, E, X and V that we have used here, it will be called, these are called symbolic statements, right? What is called compound statement? So compound statement is actually a combination of two statements. For example, John is an intelligent boy and John is a good boy. So there are two statements, but it is combined by a word and. So these two statements are actually joined or combined by a one word that is called and. So this is called a compound statement because it includes two statements. Similarly, it can be represented as I and G, because I represents John is a good boy and John is a good boy represent G, and I is represented as John is an intelligent boy. Similarly, if you wanted to write down either John is an intelligent boy or John is a good boy, you can easily write it as I or G. Similarly, if John is an intelligent boy, then John is a good boy, you can write it as if I, then G. Similarly, these are the certain statements which can be represented like this. For example, John is an intelligent boy and John is not a good boy. So for representing not a good boy, I will only write down not G, because G already represents John is a good boy. So not G means John is not a good boy. So similarly, John is an intelligent boy. If and only if John is a good boy, I can write it as I if and only if G. So now if you see this one, we are able to convert the given statement into a symbolic form, but still there are certain words and, or, not, if, then, if and only if. These are still some words which are there which we need to also convert into a symbolic statement. So for these words we again use some connectives to connect the statements, and we convert this we replace this and, or, and, not, and, then by some another mathematical symbol. So these are the logical connective which are used in place of these things that we have seen here. So not is actually replaced by this type of symbol. So this type of symbol is actually replaced by not, which is also called a negation. Similarly, disjunction is about this symbol. So or is actually replaced by this symbol, which is called a disjunction. Similarly, conjunction, which is replaced by the and, which is replaced in place of and. So this is the symbol we will use for the and, which is called technically as a conjunction. So these three connectives, why it is called connective? Because these are used to connect the given statement. These are known as basic connectives, but there are many more connectives. For example, this is called conditional connective, which is used for if and then statements. Similarly, by for representing if and only if, we use this symbol that is called this by conditional, which is has arrow on both the sides. Right. Similarly, we have XOR statement that is called exclusive OR, which is represented by two different symbols in different books. So these are the two different symbols that is actually used for XOR. Similarly, we have two more two more symbols that is called NAND and NOR. So for NAND we use up arrow, for NOR we use down arrow. These are the various symbols. Why we are using these symbols? Just to replace those words with the mathematical symbols, so that it can easily be used to apply certain mathematics on statements to draw a particular conclusion from a given set of thousands of statements. Right. So this was all about the basics of the mathematical logic, where we have seen that how the statements that are either true or false can actually be converted into a symbolic form, right? And for combining these statements, we use certain connectors which are used to connect the statement to form a compound statements, right? For example, in the previous one we have used here John is an intelligent boy and John is a good boy. It can now be represented by I conjunction G, because conjunction represents and. So now you can see that we have converted this entire statement into a mathematical form, right? So this is like a mathematical expression that we are able to convert it. Similarly, this statement is converted to I disjunction G. Disjunction means or. Similarly, if then can easily be represented by I conditional G, because conditional is used for if then. So if John is a intelligent boy, then John is a good boy. Similarly, John is an intelligent boy and John is not a good boy can easily be represented by John is a good boy conjunction not G. Similarly, John is an intelligent boy if and only if John is a good boy, which is I by conditional G, right? So this is how we are able to finally convert the given statement into a symbolic form, where we can now apply various rules to combine the statements and finally reach up to the final conclusion. So this was about the basic introduction of the subject, as well as one very important topic, or which is also a discrete structure, that is called mathematical logic, where we have started with the propositional logic. Rest part we'll be studying in the next lecture. Thank you. Thank you so much.